Hi everyone, welcome to my channel. Myself Dilip Krishna. I am pursuing my BTech degree in Sri Venkateswara College of Engineering. Today we are going to discuss a subtopic in cryptography. They are polyalphabetic cipher and one-time pad. In that we are going to discussing about the topics introduction, working, advantages, disadvantages, and conclusion. So let us go through one by one. Let us first go through the introduction. One-time pad algorithm is the improvement of the Vernon cipher proposed by an Army Signal Corps officer Joseph Maubourgne. It is the only available algorithm that is unbreakable, means it's completely secure, and it is a method of encrypting alphabetic plaintext. It is one of the substitution techniques which converts plaintext into ciphertext. In this mechanism, we assign a number to each character on the plaintext. Let us discuss about the two requirements for the one-time padlock. The key should be randomly generated as long as the size of the message. It says that the size of key should be equal to the size of the message. The key is to be used to encrypt and decrypt a single message and then it is discarded. Each it says about each key is used for each messages and it is not be repeated. The for each message the key is varying. So encrypting every new message requires a new key of the same length as the new message is one-time pad. The ciphertext is generated by the one-time pad in random, so it does not have any statistical relation with the plain text. Let us discuss about the prerequisites that are used to encrypt and decrypt the data. Mainly, we use cryptography, data encryption, and data decryption. Cryptography. Cryptography is the science and practice of designing secure communication systems that protect information by converting it into a secret code or cipher, making it difficult from unauthorized individuals to access or understand the original information without the appropriate decryption method or key. Data encryption. Data encryption is a method of preserving data confidentially by transforming it into ciphertext, which can only be decoded using a unique key decryption key produced at the time of the encryption or prior to it. Data decryption. Data decryption is a fundamental component of modern cybersecurity and is used in various applications including secure communication, data storage, and protecting sensitive information. So let us discuss about the working, how it works, and how we should going to convert. Before we start encryption, we will have to assign specific number to the alphabets which can be used in the process. Here you can see A is assigned as 0, B is assigned as 1, and C is assigned as 2, and D is assigned as 3, and so on. The Z is assigned as 25. The relation between the key and plain text. The relation between the key and plain text. In this algorithm, the length of the key should be equal to that of plain text. We are going to consider it as plain text and key. The length of the both plain text and key should be equal. Here we can understand with a simple example. Here I have considered the message as spicy and key as lower. You can see that message is 5 words and key is message is 5 letter word and the key is 5 letter word. The both the message and key is equal. Part 1, encrypting the message. Encryption means we are going to convert the plain text to ciphertext. Here you can see that converting the plain text message to numerical values using a standard mapping. We saw that the alphabets with numbers A is considered as 0, B is considered as 1, C is considered as 2, Z is 25. Here first we are going to consider the message as spicy, SPICY. We are going to assigning the values for that. S should be 18, P is 15, I is 8, C is 2, and Y is 24. Is 24. Here the keys, converting the key to numerical values in the same way as the message, considering L as 11, O as 14, V as 21, E as 14, and R as 17. And the numerical values of the message and key taking care to wrap around to the beginning of the alphabet. We are going to consider it with as modulo of 26 because the total number of 26. Uh, the encryption means we are going to finding the ciphertext. Here to find the ciphertext, we are going to add the message value with the key value. You can see the message value. The first letter of message value is S, considered as 18, and it is going to add with the first letter of key. It is considered as 11. We are going to add that 18 with 11. We are going to get the value as 29, and by doing the modulus to it, we are going to get the same value because there is no point value, so we are going to get the same value as 29. You can see here we can take the values up to 25. After 25 we are going to calculate with from starting. So here we are going to calculate the 26 as A and 27 as B and 28 as C. We got the value as 29, so we are considering D as 29. Here we got the value as D. We got the value as 29, so we are considering the 29 as D. Then the second letter of the here the second letter of the message is P. The value of the P is 15, and the second letter of the key is O. The value of O is 14. By adding the message with key, it message with key, it shows 15 plus 14. It gives the same value as 29 as above, so we can considering the 29 as D itself. Then again third letter with the I, it is I is 8, and the third letter of key value is V, and the V is considered as 21. By adding the 21 with 8, we are going to get the same value 29, same as above. We are considering the same 29 as D here also. Then the fourth letter is C. C, the value of C is 2, and the fourth letter of key is E, and the value of E is 4. By adding both the 4 plus 2, we are going to get the value as 6. Considering the 6 as G, and as we done above, we repeat the same process. We are going to get the value as 41, and considering the 41 as P, we are going to get the final value of ciphertext as DDDGP. This is the encryption, and here now we will see how the how the decryption is going on. We are going to decrypt the ciphertext. Here the decrypt the ciphertext, we are going to convert that ciphertext to message that we have considered the message as SPICY. We are going to get the final value. We have to get the converted ciphertext message as spicy. So let us check how we are going to get converting the ciphertext to numerical values. We got the ciphertext at DDDGY. So D is 29 and G is 6, P is 41. And converting the key to numerical values, key is considered as LOVR. The numerical value of L is 11 and O is 14, V is 21, E is 4, and R is 17. So let us decrypt the value. Here you can see decryption is taken as the subtracting the numerical value of the key from the ciphertext. Here we are going to subtract the numerical value of ciphertext with the key. We are going to subtract the key with the numerical value of ciphertext. Here you can see the numerical value of ciphertext is 29, and numerical value of key is 11. We are going to subtract this 11 with 29. We can get the value as we can after subtracting we are going to get the value as 18. uh, by getting the value as 18, we are going to modulus the 18 with the 26. We are going to get the final value as 18, and the value of 18 is s. We are considering the 18 as s, and again the second one, again you can see we are going to subtract this 14 with 29. 29 minus 14, 29 minus 14, we are going to get the value as 15. The 15, the numerical value of 15 is p. Numerical value of p is 15. And by continuing the same process, we are going to get the third value as I, and the fourth value as c, and the fifth value as y. That is fine though. So the final decrypted message is spicy. You can clarify this with we consider the message as SPI. After encrypting this spicy, we got the message as DDDGY. After decrypting the DDDGY, we got the same message as SPICY with using the key as LOVR. So this is how the encryption and decryption of messages will be taking place. By this, the message will be highly secure, and it can't be pretend by someone else. So let us discuss about the advantages. There are many advantages. I have listed some advantages. One is perfect secrecy. Perfect secrecy. It provides theoretically unbreakable encryption when used with truly random, never repeated keys. Truly random and never repeated keys. Unpredictable encryption. It's immune to traditional cryptographic attacks like frequency analysis. The third one is no patterns. Ciphertext reveals no patterns, making it resistant to decryption attempts. Sec- uh, so let us discuss about the disadvantages. First disadvantage is key distribution. Securely sharing and managing keys can be challenging, especially over long distances. Vulnerability to key comprise. If the key is compromised, all past and future messages are at risk. So we can easily hack that message. Inefficiency. The key must be as long as the plaintext, making it inefficient from encryption. Large volumes of data, lack of authentication. It doesn't provide authentication or integrity checks, leaving it vulnerable to certain attacks. Vulnerable to certain attacks. Final conclusion. The one-time pad cipher represents the pinnacle of security in cryptography. Despite its changes, it finds a place in high security contents. As we journey through the world of cryptography, let's keep in mind the words of Bruce Steiner and Alan Turing. The cryptography is the science of secret writing, and we can only see a short distance ahead, but we can see plenty there that needs to be done. So this is all about polyalphabetic cipher and one-time pad. Thank you.